Hey everyone, in this video we'll see that how we can delete any element from the end of a doubly linked list. Let's start. So at first what we'll do, we'll traverse the entire list and we'll store the last node in a separate pointer, that is del or temp, whatever you call. Then we'll set the last priv next as null. This is the most important portion. Last priv next. You just think in your mind that what is last priv next. Last priv next. Then we'll free the memory of the last node. So what is last priv next? So let's say that this is the list. As you can see in my screen, one list is there, doubly linked list. So last priv next. So what is the last node? Last node is FFF4. Last priv, it means FFF2. This node. Last priv next. Last node, priv node, and next node, that is this pointer. So last priv next means this portion. We have to set this portion as null because null is the terminating point for the double pointer. Now how the list will look like? The list will look like this. So we have set the last priv next as null. So it contains null. Then what we'll do? It means this connection has been discarded. We'll just free this memory. I think this portion is clear. Let's look at the algorithm. Delete at the end. Node head global. So let's say that we have a global node, that is head. It has something in it. Now let's say that this is A, B, C is pointing to B, B previous A, B next is C, C previous B. If head next equals to null means we have only one value within a list. This is null. So what we'll do? We'll take a pointer, that is del. Del will be pointing to this node. Then we'll assign null into head. It means this connection has been discarded. Head is null. We don't have any value within our head. Then we'll just free this del. We'll just free this del. Now we'll look at the else condition. So you can also put a condition here. We have put a condition in our code that if head equals to null, it means we don't have any value, so we'll just return. So that condition we have put in our code. So here we don't have much space in this slide, so that's why we haven't put that condition. So you have to remember that in your mind. Now we have to go t next not equals to null. T next not equals to null means at first what is the value of t? Let's say that the value of t is a. T next means b. B not equals to null. Then we'll just move t into t next. It means t will be pointing to this node, that is b. So t next equals to what is the t next, that is c. Now c is not equals to null. So again we'll move t to t next. It means what will be the value of t, that will be c. Then we'll again check what will be the value of t next. The value of t next is null here. So it means this condition won't be satisfied. Then what we'll just do, we'll just assign, we have taken a del pointer. Del will be pointing to this node. We have assigned t into del. Then we have put t priv next. T priv next means what is the value of t? The value of t is c. T priv next, it means t. What is the value of t priv? That is b. This node and this node next, it means c. We'll put null over here. We'll just put null over here. Then we'll just free this del. It means we have successfully deleted the last node. So this is how we can delete the last node from our doubly linked list. So I think this portion is clear. Let's start with the hands-on. So as you can see in my screen that we have declared the structure. This is the head node, this is the create node, this is the insert function. Then we are calling this function delete at end. So here as you can see that at first we have declared that if head equals to null, it means we cannot delete anything. This condition is for deleting a single element when we have only one value within a list, and within else this is the condition for deleting the last value. If we have only one value in our list, it means that is the last value. So this is a traverse function, and how many times we are calling this delete at end? We have inserted 3 times. We are calling this delete at end 4 times. It means at the last time we have the empty list. So I have just compiled the code. Let's say 10, 20, 30. So as you can see that at first, how many nodes present in the list? That is 10, 20, 30. At first we have deleted the last value, that is 30, deleting 30. Then how many nodes we have in the list? That is 2, 10, 20. We have deleted the last value, that is 20. At last node present in the list 10, we have deleted the value, that is 10. Now then we are traversing. For this traverse function, we are printing that no data present in the list, no data present in the list. So this is how we can delete any element from the last of a doubly linked list. I think this portion is clear, that how we can delete an element from the last of a doubly linked list. If you have any doubt, just write in the comment section. See you in the next video.